Conjugates are two binomials whose only difference is their sign. We saw this in an earlier chapter when talking about binomials. So an example of conjugates would be x plus 5 and x minus 5. And remember, when we multiplied these, we would FOIL them out. We would get x squared minus 5x plus 5x minus 25. And the inside and outside terms add up to 0, so we're left with x squared minus 25. This fact will be very important when we're multiplying the conjugates. So conjugates can be used to simplify a radical expression that contains two terms in the denominator. So let's look at some conjugates. For example, radical 2 plus 3, its conjugate would be radical 2 minus 3. So now we're looking at conjugates with radicals in them. Square root of x plus the square root of y, its conjugate would be square root of x minus square root of y. We could have square root of 3 plus x, square root of 3 minus x. These are all conjugates. So how can conjugates help us rationalize denominators? Well, if we have a radical expression 1 over square root of 2 plus 3, well, we need to multiply the denominator by its conjugate, radical 2 minus 3. And we have to multiply the numerator also by this conjugate, because radical 2 minus 3 over radical 2 minus 3, again, that's another name for 1. So what we're going to have to do here is our numerator will have square root of 2 minus 3, and here we need to FOIL these conjugates, and again, the outer and the inner terms add up to 0, so we really just have to find the first and last products. So square root of 2 times the square root of 2 is 2, then minus 9. So we're left with square root of 2 minus 3 over negative 7. So now that denominator has a rational number. Let's take another example. Let's say we have square root of 2 plus the square root of 3 over radical x plus radical y. So we're going to have to multiply by the conjugate of the denominator, which is square root of x minus square root of y. Square root of x minus square root of y. Now we're going to have to FOIL what's on top. So we're going to have to do some FOILing. So square root of 2 times square root of x is square root of 2x minus square root of 2y plus square root of 3x minus square root of 3y, because we're multiplying all these radicals. The denominator will be square root of x times the square root of x, which is x. And then the last term, square root of y times square root of y, is just y. And this expression is simplified. We have x minus y is rational, and each of the radicals in the numerator are not like radicals. They're all different, so they cannot be combined. So even though this looks maybe a little bit different, doesn't look all nice and neat, it's still a simplified expression with a rational denominator.